Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving past paper questions of IGCSE Physics 0625. Since the results for October-November sessions are out, so the papers are now available as well. So today we are going to be solving the 2025 paper for October-November, and the variant is P22. So let's start. But before we begin, kindly like and subscribe the channel. And if you find anything helpful in the video, kindly remember me in your prayers. Thank you. Let's start. Question number 1. Which quantities are both vectors? A. Acceleration and force. Yes, they both are vectors because they have direction as well as magnitude. Acceleration and pressure, this is vector and this is scalar, so this is not correct. Density and force, this is vector, but density is a scalar quantity, so this is also not correct. Density and pressure are also not correct. So A is our correct option. Okay, question number 2. How is the deceleration of an object calculated from a speed time graph? Okay, we know that in the speed time graph, the gradient gives us the acceleration or deceleration, whereas the area under the graph gives us the distance. So if you've got to measure the deceleration of an object, so it is not going to be area under the graph, because that area under the graph gives us the distance. It is the gradient of the graph. B, which is the correct answer. It is the difference between two readings on the horizontal x-axis. No, it's the difference between the two readings on the horizontal x-axis and divided by the two readings on the vertical y-axis. So both of them are incomplete. So these are not our options. Question number 3. A space probe has a mass of 600 kgs, is on planet Mars. The acceleration of free fall on Mars is 4 meters per second square. What is the weight of the space probe on Mars? So we can connect all these quantities with the help of a formula. W is equal to mg. We know what is the mass, 600 kgs. The unit is also perfect. And we know the value of the free fall on the Mars, which is 4. So 600 into 4 is going to give us 2400 newtons. So the weight of this space probe is 2400 newtons. Moving on to question number 4. Students are asked to predict the order in which the three liquids P, Q, and R will float on each other. They are told that the liquids will not mix. The diagram shows how the density of the liquid P is determined. Okay, since they've told us that these liquids are not going to mix, so we know that all these liquids have different densities. Okay, so we've been given the density of the liquid Q and R, and we have to calculate the density of the liquid P. So density can be calculated with the help of the formula. Density is equal to mass over volume. So we have a mass of 69 grams. We have a volume of 20 centimeter cubes, and the mass we have to calculate. So the mass of this measuring cylinder without the liquid was 45 grams, and with the liquid is 69 grams. So the mass of the liquid is going to be the total mass subtracting the mass of the measuring cylinder. So 69 minus 45 is going to give us 24 grams. And if we substitute this in the formula, so it's going to be 24 over 20, which is going to give us a density of 1.2 grams per centimeter cubes. ठीक हो गया? So now we know the density of all the three liquids. So the density of P is 1.2 grams per centimeter cubes, of Q is 0.75 grams per centimeter cube, and of R is 1.1 gram per centimeter cube. So now we know that the liquid which is the most dense is going to be in the bottom, and so on. So we can see that liquid P is the most dense one. So this is going to be at the bottom. The next one is going to be R, and the last and on the top is going to be the liquid Q, which has the smallest density out of the three. So we have P, R and Q. So let's look at our options. P, R and Q. Option C is the one that matches all our logic and description. So C is going to be our correct answer. Okay? Question number: a force F applied to a spanner as shown. Which action increases the moment of force about the center of the nut? Okay. First thing that we should know is that moment is equal to force into the perpendicular distance to the force, okay, to the pivot. If now look at the options, applying the force F to the right hand end of the spanner handle, okay. Applying the force F parallel to the spanner handle, okay. Spraying oil on the nut and using a shorter spanner. So they've asked us that which action is going to increase the moment of F. Moment is going to be increased if either the force or the perpendicular distance from the pivot is increased. Okay, since moment is directly proportional to both of these entities. So if we look at our options, our option D states that using a shorter spanner. So if the spanner is going to be shorter, the perpendicular distance is going to be decreased. Okay, na? And we want to increase the moment. So our option D is not applicable over here. C, spraying oil on the nut. This is going to reduce, help us reduce friction and has nothing to do with moment of force. So this option is also not applicable. Applying the force F parallel to the spanner handle. If we do that, if we apply the force parallel to the spanner handle, that would make the perpendicular distance 0. And if that is 0, the resultant moment is also going to be 0. If one of these is 0, so this multiplied by this is going to give us a 0 moment. So this can't be it. Okay, na? So A, applying the force F to the right hand end of the spanner. This is our correct answer, because if we apply force to the right hand, it increases the perpendicular distance, and since one of these entities has increased, so this is going to increase the moment. I hope it's understood. Question number 6. Diagram 1 shows a ball of mass 0.15 kgs traveling horizontally with a velocity of 2.1 meter per second towards ball Y, traveling at 0.4 meter per second in the opposite direction. Okay. Diagram 2 shows the velocities of the balls immediately after they collide. Okay. So the info that we have is that this ball is 0.15 kg and is traveling in this direction with a velocity of 2.1 meter per second. The mass of ball Y is unknown, and it is traveling in the opposite direction to that of X with a velocity of 0.4 meter per second. After they collide, this ball of mass 0.15 kgs travels in an opposite direction to what it was traveling before with a velocity of 1.4 meter per second, and the ball Y, whose mass is unknown, then travels in the opposite direction with a velocity of 1.1 meter per second in the opposite direction to its initial motion as well. Okay. Now the crux of this question lies in the fact that how much you know your concepts regarding momentum. We know that momentum is a vector quantity. It has direction as well as magnitude. And we need to know that if this ball is traveling in the right direction and this one is traveling opposite to it in the left direction. So one of these velocities is going to be positive and the other velocity is going to be negative. Since the momentum needs direction as well as magnitude when it is being represented. So these negative and positive sign tell us that actually these two objects or balls are moving in the opposite direction. Okay. You can take any quantity to be positive and any quantity to be negative. If you take this quantity to be negative and this quantity to be positive, it's just perfectly fine. It's up to you. One has to be negative, one has to be positive, and you can decide which one you're taking as positive. So we are taking the direction towards right as positive and the one towards left as negative. But now if you see in the diagram 2, this ball X, which was previously moving in the right direction, is now moving in the left direction. Okay? So now this has to be assigned a negative value, since the one moving towards the left was assigned the negative value before. Okay? And now this ball is moving in the right direction, and we see that over here we took the right direction to be positive. So now this is going to be positive. Okay? So this is the crux of the question. If you can do this, the calculations are never going to be an issue. Okay? I hope you understood what I've told you, that you've got to take one of these velocities to be negative and one to be positive, because these velocities are in opposite directions. Okay? They have to be represented by a positive and a negative sign. Okay? So once we've established this, we are going to take the mass of X to be m1 and its velocity to be v1, and the mass of Y to be m2 and its velocity to be v2. Okay? So since it's a question related to the momentum before and after the collision, so we are going to take help from the law of conservation of momentum, which states that the momentum before and after collision is conserved. So what are we going to write is m1, the mass of the first ball with its velocity v1, that is the initial velocity, and then mass 2 and its initial velocity. Okay? You can write u over here, you can write I over here, you can write whatever you want over here. Okay? It's up to you. The examiner is not going to mark it somehow. Okay? Acha. It's equal to m1, the mass of X, with its final velocity. So over here you can write Vf, over here you can write V2, whatever you want. Okay? And the mass 2 with its velocity 2. Okay? Now we know that the mass 1 was equal to P 0.15 and its velocity, initial velocity, was 2.1, and which was positive, which we've taken as positive. Okay? And m2 we don't know, and v1 was 0.4 and we took it to be negative. Okay? Because it was in the opposite direction of this one. Then we have m1 again, 0.15, with its velocity 1.4, final velocity, which is 1.4, and now the direction has changed, so it's going to be negative, minus 1.4, and we will be having m2 that we don't know anything about, and the final velocity of the ball Y is going to be 1.1, and since it has also changed direction, first it was negative, now it's moving in the opposite direction, so it's positive. Okay? So now let's make the calculations. So 0.15 into 2.1 is 0.315, and m2 with negative 0.4 is going to stay here, and 0.15 into negative 1.4 is going to, let's do it over here, so that we have enough space and you can understand that better. So 0.15 into negative 1.4 is going to give us negative 0.21 plus M2 with a positive this. So we are going to add this over here, and M2.4 is equal to M21.1. Okay, so this is going to give us an answer of 0.525. Let's take this M2 over there, negative. So 0.525, let's take M2 as common. M2, so 1.1 and negative multiplied by negative is positive. So this is going to be 1.1 plus 0.4, and this is going to give us an answer of 1.5. So 0.525 divided by 1.5 is our mass M2, which is 0.35 kgs. So this is our answer C. I hope you understood the explanation of this question. I think the calculations are a bit much for just 1 mark question, but they are not difficult. So if you understand the concept of momentum, so you will inshallah be able to do it. Question number 7. A mass is suspended from a vertical spring. The mass is pulled downwards, causing the spring to extend further. The mass is held in this position and then released. Which energy changes occur during the initial momentum of the mass when the mass is released? Okay, now what they are telling us is that there is a vertical spring and a mass was suspended from it. So obviously the spring got extended, but they are not asking us about the energy changes that occurred when the mass was suspended from the spring and when it got extended. They are asking us about the fact that when the mass was removed, so what were the changes that happened after that? Okay, so obviously firstly when the mass would have been suspended, so the spring would have been extended. So it means that elastic potential energy would have increased. Okay, and since it was having some sort of movement, the kinetic energy would have increased as well. And this kinetic energy would be there because gravitational potential energy store was decreasing and kinetic energy store was increasing. Okay, so this is what happens when the mass was suspended from the spring. Now once the mass has been removed, so we know that the extension is going to return to normal. Okay, and so the elastic energy is going to decrease. Okay, na? It is going from this to this position again. So elastic energy is going to decrease. Now there is some sort of a movement in the spring. So as the movement is there, the kinetic energy is going to obviously increase. And since the spring is moving backwards, is being compressed backwards, and this is happening against the gravity. So gravitational potential energy is going to increase as well. Okay, so elastic energy is going to decrease, kinetic energy is going to increase, and gravitational potential energy is going to increase as well when this scenario is being discussed, when the mass has been removed and the spring is compressing back. ठीक है. So let's now look at our options. Option A, gravitational potential energy decreases. No, it has to increase. Kinetic energy decreases. No, it has to increase. And elastic energy has to decrease. So this option is not applicable. Decrease wala option, gravitational potential energy ka is not going to happen, and elastic potential energy is not going to increase since it's being compressed and not stretched. C states the gravitational potential energy increases. Correct. Kinetic energy decreases. No, kinetic energy has to increase as well, and elastic potential energy decreases. This is correct, but all the three options don't match. So D, increases. Kinetic energy increases and elastic energy decreases. This is our correct option. Moving on to question number 8. Which energy resource stores kinetic energy? Coal stores chemical energy. Nuclear fission जो है उसके अंदर there is nuclear reaction, so this doesn't work. In solar में there is infrared, and wind may obviously there is going to be kinetic energy because wind blows and then the energy is obtained. So D is our correct option. Moving on to question number 9. Two beakers are filled to the same depth. Okay, one with water and one with oil. The density of the water is 1000 kg per meter cube. The density of the oil is 920 kgs per meter cube. So basically the density of oil is less than that of water. In which position is the pressure the greatest? Okay, now we know that in case of liquids, we have our equation, pressure is equal to rho GH, where rho is the density and G is the value for gravitational constant, and H is the height. So pressure basically, gravitational constant is 9.8 and it remains the same. So pressure basically depends upon the density and then the height. ठीक है? So greater the density, greater the pressure, greater the height, greater the pressure. ठीक है? So if we look at our options, so basically the points are nearly at the same heights. So height is now can be ignored over here. We have to look at the pressure densities. So the density of water is more than the density of the oil. So a point over here in water which has more density is going to experience more pressure than this point over here, which is in a liquid which has a lower density. So B is going to be our correct option. Since the heights are just the same for these points, so height obviously is not something we are considering at the moment. We are going to consider the second entity, which is density, right? So B is our correct option. Question number 10. The pressure of the air in a car tire rises after a long journey. This is caused by the change in the average speed of the air particles and a change in the temperature of the air in the tire. Which row describes the change that have caused the air pressure in the tire to rise? Okay, now we have been given two entities, which one is average speed of the air particles and the other is the change in the temperature. We know that whenever there is a mention of a change in temperature in a space that has a fixed volume, so we know that whenever there is an increase in the temperature, the kinetic energy of the particles has to increase, right? So when the kinetic energy of the particle increases, they collide with the walls of the container more frequently, ठीक है? And when they do that, the momentum increases and force, you know, is also defined as change in momentum over time. So when this momentum increases, the force also increases. And when the force increases, the pressure is equal to force over area. Since the area is not under discussion at the moment, since the area of the tire is fixed, so when the force increases, the pressure also increases. So this is all the logic behind this scenario. So obviously, when the temperature has increased, so the kinetic energy of the particle increases and they move with greater speed. Okay? So if they are asking us to choose an option for the average speed of the air particles, the average speed of the air particles is going to increase and not going to decrease. So our option, correct option, is going to be out of C and D. So temperature of the air obviously increases as well, since the tire has a friction with the road, and due to this all this movement and everything, so temperature is increasing, so temperature is also going to increase, and because the temperature increases, so the average speed of the air particle also increases. So D is going to be our correct option for this. Okay. Question number 11. In which range of temperatures is water a liquid? Okay. Achha, keep an eye on the fact that they have given you the scale for the temperature in Kelvin and not degree C. You know that the liquid melts and freezes at 0 degree C and boils at 100 degree C. So at both these temperatures and the temperatures in between these, the water is going to be liquid. At a temperature below this temperature, it's going to be solid, and above this temperature, it is going to be gas. So if we look over here, 0 Kelvin is equal to minus 273 degrees C. So water cannot be liquid at this temperature, and increasing it to 100 Kelvin is going to be minus 173. So obviously this is not going to work. 0 Kelvin again is minus 273 degrees, and to 273, taking it to 273, increase इसमें आप कर दो, so this is not going to work. 100 Kelvin obviously is equal to minus 173 degrees, and water cannot be liquid at this temperature. 273 Kelvin is actually equal to 0 degree C, and then increasing it to 373 is like taking it to 100 degree C. It's been increased by a factor of 100 now. So 0 degree से 100 degree C tak, this is our option where the liquid water is going to be liquid. Okay? Because the freezing point and the melting point of the liquid water are the same. Okay? So that is how we do it. Keep an eye on the fact that this is Kelvin and not 0 degree C. Okay, question number 12. The diagram represents the particle arrangement in samples of 3 different substances P, Q, and R. This is substance P, this is substance Q, and this is substance R. These two seems to be fluids. This is liquid, some sort of liquid, and this is gas, and this seems to be solid. The samples have equal volumes and are at the same temperature. Okay, the samples are heated. The temperature increases of each sample, the temperature increase of each sample is the same, and no change of state is taking place. Okay, which row shows possible percentage increase in volume of the 3 samples? Acha. We can see that this one is a liquid, this one is a solid, and this one is gas. So if the state isn't changing, so gas is going to be something which will have the greatest increase in volume. The liquid would be on number 2, and the solid is going to have the least increase in volume due to their arrangement. This have little spaces between them. The particles can slide past one another. These are at huge distances from each other, and the solids are just tightly packed in a lattice. So the greatest increase in the volume would be seen in the substance R, and then it would be substance P, and then it would be substance Q. Okay, so we would see and mark it correct, the one which shows the least amount of volume increase in the sample Q. So if we look at these, this is the least increase. 1.9, this is on the second number, and 7.2, this is the greatest. So C is going to be our correct option. The greatest percentage increase of volume is seen in substance R, which was a gas. The least is seen in substance Q, which was a solid. And this intermediate one is the sample B, which was a liquid. Right? So C is our correct option. Question number 13. A cup contains 0.25 kgs of water at 60 degrees centigrade. Sometimes later the water has cooled to 20 degrees centigrade. How much energy has been transferred from water to the surrounding? The specific heat capacity of water is taken to be 4200 joules kg per centimeter cube. So we know that all these entities can be joined together in a formula. Energy is equal to Cm delta T. So energy is something we've got to find. The specific heat capacity of water is 4200. Mass is given in kgs. No need to change the units. And delta T, which is the change in temperature, is 60 minus 20. So that's going to be 40. So when we multiply all these entities together, we get an answer of 42,000 joules. So B is going to be our correct option. So this was a pretty straightforward question. Question number 14. A pure substance is heated slowly. The temperature of the substance is measured as it starts to melt and when it finishes melting. Which statement is correct? The temperature decreases slightly as the substance melts. Okay, the temperature fluctuates as the substance melts. The temperature increases as the substance melts. Okay, the temperature stays the same as the substance melts. Okay, D is our correct option. And why? You've seen the heating and the cooling curves. So we know that whenever there is a state change that is happening, so over there, the temperature remains the same. For example, we've started to melt something. Okay. So, here it's going to be a change in temperature, but when the state change is happening, the temperature remains constant. When the state changes, again, that if the temperature is being provided, if the heating is being provided, the temperature again increases. And then whenever there is a state change, so it remains constant. So that is why the temperature stays the same as the substance melts, because there is a state change that is happening. Okay, it gets heated, and when the state is changing, so the curve is straight, it never changes. So if the state was not being changed, if it was just mentioned that it is being melted, so it would have been a different story. But at this point, when the substance is melting, so a state change is taking place, so the temperature is going to be constant. Okay. Question number 15. A lamp has a metal filament that glows when heated by an electric current. The middle of the filament has a very high temperature. The ends of the filament are connected to the base of the lamp and are cooler. Which statement is correct? A. Some thermal energy is conducted to the base of the lamp. Okay. The filament radiates energy equally at all points along its length. Okay. The lamp transfers all of the input energy as visible light. Okay. And when the potential difference across the filament is halved, the power output is halved as well. Acha. The answer to this question is that some thermal energy is being conducted to the base of the lamp. Okay. And why are the other options not our answers? Let me tell you. The option B states that the filament radiates energy equally at all points along its length. And they've already mentioned that the middle of the filament has a very high temperature and the ends of the filament are cooler. So this means that the filament isn't radiating energy equally at all points along its length. So that is why B is not our option. Option C is that the lamp transfer all of the input energy as visible light. We all know that whenever there is a metal filament and it glows, so some of the energy is being transferred into heat energy. Okay, so that is why this option is not applicable. D, when the potential difference PD across the filament is halved, the power output is halved as well. Now you are familiar with the formulas of the power. This one you are very familiar with. The other formula for power is V square over R. So you see that according to this formula, if the power is halved, if the PD is halved, the output power will be quartered. ठीक है ना? It won't be halved because it's V square and it's just P. So this also is not applicable. Why are we selecting this one? Because we know that heat flows from a hot body to a colder one. So the middle filament is hotter than the ends, and so some of this energy is being conducted to the base, okay, along the metal filament to the cooler base of the lamp. Okay, so that is why this is the correct answer and all other answers are incorrect. Okay, so moving on to question number 16. A liquid passes through pipes inside a refrigerator. The liquid warms as the inside of the refrigerator cools. They work vice versa. The warm liquid is then passed through pipes on the outside of the refrigerator to cool it before it goes back through the refrigerator. The diagram shows two designs for the outside cooling pipes. One design has copper rods called fins attached to the pipes. Okay. The outside of the pipes and the fins can be painted silver or black. Which design of outside pipe will cool the liquid most quickly? Achha, now whenever the thermal physics is concerned, so you should always remember that black is something that absorbs heat very readily and then it radiates it very readily as well. Something which is light, white colored or silvered colored, so it's going to reflect the heat that is coming towards it and it is a poor absorbent. Okay, so black is a good absorbent and black is a good radiator as well. So anything that has to do with radiation being to the optimal, so you should always be using something which is dark colored or black. Okay, and it should be matte as well. Okay, silver would be light colored and silver would be shiny as well. Okay, as opposed to black. So when they are asking us that which design of outside pipe will cool the liquid most quickly, so it would be something which is black. Okay, and it's not silver or light colored. So our options would be painted black with fins and painted black without fins. Okay, so we are going to select option B. Okay. Okay, now we've understood that why black is being used, and now it's time to understand why the option with fins would be more suitable, because these fins increase the surface area available for heat transfer. So increasing the surface area will cool the liquid down much more quickly at a higher rate. Okay, so that is why fins are used and black color is being used, right? So this is the logic. 17, an earthquake monitoring station records the arrival of 16 complete wavelengths of an earthquake wave in a time of 20 seconds. The speed of the earthquake wave is 6 kilometers per second. What is the wavelength of the earthquake wave? Okay, all these entities are joined together by the formula V is equal to F lambda, where V is the speed, F is the frequency, and lambda is the wavelength. So we already know the speed, which is 6 kilometers per second. But you should also see that the answers are in meters and not in kilometers. So we've got to convert this into meter per second. So 6 kilometers would be 6,000 meters per second. And we have to find the frequency as well. So frequency is number of waves over the time. So there are 16 complete wavelengths over time would be 20 seconds. So this is going to give us an answer of 0.8. So this is 0.8 lambda 6000 divided by 0.8 is going to give us a wavelength of 7500, and it can be written as 7.5 into 10 raised to the power 3 as well meters. So D is going to be our correct option. Moving on to question number 18. Which statement is correct? A. Seismic S waves are longitudinal. Sound waves are longitudinal. Yes, this is absolutely correct. The amplitude is always greater than the wavelength in a longitudinal wave. Not really. The vibration is at right angles to the direction of propagation in a longitudinal wave. No, it's in a transverse wave. Okay, there are two types of waves as we know, longitudinal and transverse. Seismic S waves come under transverse waves, and the P waves come under the longitudinal waves. Okay, and sound waves are longitudinal, so this is absolutely correct. Amplitude being greater than the wavelength, not really, not in all circumstances, so this is not correct. And the vibration, I've just already told you that in longitudinal waves, the vibration is parallel to the direction of the propagation in a longitudinal wave, and it is at right angle, or it is perpendicular to the direction of the propagation of the wave in a transverse wave. So that is why these options are not correct, and our option B is absolutely correct. Question number 19. A water droplet is falling towards a horizontal plane mirror. Okay. At one moment, the droplet is at a distance of 1.5 meters above the mirror and falling at a speed of 2 meters per second. Okay. What is the distance between the droplet and its image? And what is the speed of the image at this moment? Okay. So let's just understand the scenario. So this might be a plane mirror, and a water droplet is falling at a speed of 2 meters per second towards it. And at one point, the distance of this droplet from the mirror is 1.5 meters. Okay. As we already know that these properties of, we've studied in the properties of plane mirror that the image distance from the mirror is the same as is the object distance from the mirror. So if this droplet is 1.5 meters away from the mirror, then its image would also be 1.5 meters away from the mirror. ठीक हो गया? And they've not asked us that how much far is the droplet image from the mirror. They've asked us what is the distance between the droplet and the image formed. So this is the whole distance that is required. Okay, so this is 1.5 and 1.5, so this is going to be 3 meters. The distance between the droplet and its image would be 3 meters because it is 1.5 meters away from the mirror. The image is also 1.5 meters away from the mirror. So this distance is 3 meters. Okay? And obviously everything else is just same in the mirror. The speed, the distance, the size, it's just laterally inverted and nothing else. So the speed of the image would be 2 meters per second. Okay? So 3 and 2, C is going to be our correct option. Okay. Moving forward to question number 20. Total internal reflection may occur when light reaches air glass boundary, okay? Under which condition is light totally internally reflected? Okay, there are two conditions that have to be met for total internal reflection to happen. The first one being that the light should move from a dense to a less dense medium. Like it should emerge from water and go into air, or it should emerge from solid and go into air. So it should be traveling from a more dense medium to a less dense medium. Okay? And the second one would be that the angle of incidence should be greater than the critical angle. Okay, these two are the requirements for total internal reflection to occur. So now let's go through our options. Medium in which light travels towards the boundary. So it should be glass, because glass is more dense than air. Okay, so air to kisi सूरत नहीं हो सकता. तो glass is the option over here. And angle of incidence should be greater than the critical angle for total internal reflection to occur. So C is going to be our correct option. So you can easily ace the paper if you know your concepts. If you don't know your concepts, so obviously you are going to get confused while sitting there in the examination hall. So go through your concepts very thoroughly. This is the time if you are appearing in May-June session of 2026. So this is the time to go through your concepts and practice them using topicals, and then move to yearly past papers. So kindly go through these thoroughly. Moving on to question number 21. A long-sighted person cannot see objects clearly that are short distance away because the image is blurred. Where is the image formed relative to the retina, and which type of lens is used to correct long-sightedness? Okay, for long-sightedness, the image of an object, if this is the eye and this is the retina, so the image of the object would be formed somewhere beyond retina. Okay? That is why it is blurred, and it can be corrected using a converging lens, obviously. So the position of the image would be behind the retina, and it can be corrected using a converging lens. And for short-sighted person, the image is going to be formed before retina, and it would be corrected using a diverging lens. Okay, so this is it. Question number 22. What is the speed of infrared radiation in glass with a refractive index of 1.5? Okay, so we have a refractive index. We've got to find the speed of infrared radiation in glass. We already know the speed of infrared radiation in air. So the formula that we are going to use over here is refractive index is equal to speed of infra in air by speed air, or you should say vacuum. Speed of infra in glass. So this is 1.5. This we know to be 3 into 10 raised to the power 8, and this we've got to find. So this is going to go there. 3 into 10 raised to the power 8 divided by 1.5 is going to give us the speed, and it is equal to 2 into 10 raised to the power 8 meter per second. So B is going to be our correct option. Moving forward to question number 23. Question number 23. Sound travels through air as a series of compressions and rarefactions. Which statement correctly compares a compression with a rarefaction? A. In a compression, the wavelength is longer than in a rarefaction. Okay. In a compression, the wavelength is shorter than in a rarefaction. C, in a compression, the density of the air is greater than in the rarefaction. D, in a compression, the density of air is lower than in the rarefaction. Okay, now coming to the statement A and B, in a compression, the wavelength is longer than in a rarefaction. So, wavelength is a property of the entire wave, okay? And it is not a specific region attached within it. Okay, na? So these wavelength options are not applicable over here. Wavelength is obviously a wavelength encompasses or is the property of the entire wave. So that is why these are not applicable. And we know that in the compression, we define compression as an area which is denser because the air particles, air molecules are compressed over here. Whereas in rarefaction, they are easily scattered. So we know that in a rarefaction, the particles of air are packed together. So if they are packed together, the density is all obviously going to be greater than in the rarefaction. You can see this is a compression and this is a rarefaction. So C is going to be our correct option for this. Question number 24. Which statement about magnets are correct? Permanent magnets are made up of steel. Yes, this is correct. Electromagnets are temporary magnets. This is also correct. C, a magnet can be used to induce magnetism in an iron bar. Yes, this is also correct because iron is a magnetic material. So option 1, 2, 3 all are correct. A correct answer option is option A. Question number 25. In a circuit, two identical lamps are in parallel. The parallel pair of lamps is in series with a resistor and a battery. The battery does 120 joules of work, moving 50 coulomb of charge around the circuit in time t. In each lamp, 40 joule of work is done by the charge that passes through it in time t. The electromotive force of the battery is E, and the potential difference across one lamp is V. Which statement about E and B is correct? Okay, so this is an interesting question. So we can easily find RE, okay, which is the EMF of the battery. Okay. We have a formula for that, which is EMF is equal to work done by battery divided by the charge moved. ठीक हो गया? So the work done is mentioned to be 120 joules, and then the charge is 50. So this is going to give us 2.4 volts. In order to understand the PD across one lamp, which is V, we must draw the circuit. Okay? So there is a battery and here is a lamp. Okay? There is another lamp which is parallel and identical to the first one, and there is a battery and a resistor in series with these two lamps. Okay? So now we know that the lamps are connected in parallel. So the total charge from the battery, which is 40 coulombs, which is 50 coulombs, is going to be equally divided between these two lamps. Okay? Since these lamps are identical, okay? They've mentioned that these lamps are identical, so the charge is going to be divided equally. So if the charge is 50 coulomb, so one of these lamps is going to have a charge of 25 coulombs. Okay? In a series circuit, these are equally divided between identical components. So we have a charge of 25 coulomb when it comes to one lamp. Okay? So when we find the PD through the same formula, that is work done by one lamp. Now this is one lamp. Keep in mind, they didn't ask us for the work done in both, the PD in both the lamps. They asked us that the potential difference is across one lamp only. By the charge moved through one lamp only. Okay, so the work done is going to be 40 joules, and the charge moved is going to be 25, half of the total. So this is going to give us an answer of 1.6 volts. So E and V का statement, if something has to be corrected, तो the B is our correct option. ठीक है? Read the question carefully, draw the diagram in order to understand the scenario, and then solve the question. ठीक है? The trick part in this question was that the PD was across one lamp. You could have easily calculated it by dividing 40 with 50, but they wanted the charge in one of the lamps, not both the lamps. Okay, so if one was involved, this charge had to be divided equally among these two identical lamps. Okay, so that is how we do this question. Moving on to question number 26. Two wires X and Y are made from the same metal, okay, and have the same resistance, okay. Which row identifies a possible pair of values for X and Y? Okay. So we know that resistance is equal to length of the wire by the area or diameter square. Okay, so let's take in the values. These values are just the same. So just first let us find out what this wire holds. So 50 divided by 0.40 square is 312.5 ohms. Okay, the resistor for wire X, for this wire with a length of X and diameter of X is this. Now let's find out the pair of values that gives us a resistance of 312.5 ohms. So first is 200, the length is 200, and this is over here. So this gives us an answer of, let me solve all these and then get back to you. 200 by 0.20 square. So for the first pair of values, our resistance was 20,000 ohms. For these values, our resistance was 5,000 ohms. And for these values, our resistance came out to be 312.5 ohms, which is identical to this. So C is our correct option, where X and Y are of the same metal and have the same resistance. Okay. Moving on to question number 27. Which circuit contains a light dependent resistor LDR? Okay. You should always go through your electrical symbols. You should know them by heart, because sometimes there are questions like, what is this symbol? And if you get confused between a resistor, variable resistor, and LDR, so it is going to be a disaster. You are going to lose your marks. So learn them by heart. So they are asking us about a circuit that contains light dependent resistor. So light dependent resistor is D. What are the other ones? This is a variable resistor. Okay. This is the symbol of a heater. And this is a thermistor. So D, this is an LDR. Go through these symbols before your exams. Kindly go through them. Okay. A teacher asks 3 students to write down an equation to determine the combined resistance RC of the resistors with resistance RY and RZ. Which students are correct? Okay, these two resistors are connected in parallel to one another. So the equation would be 1 by RC is equal to 1 by RZ plus 1 over RY. So this is going to be it. So let's see which one matches ours. 1 by RC, 1 by RY, 1 by RZ. This is correct. 1 by, no, this is not correct. And 1 by, no, this is also not correct. This has to be 1 by RC. So 1 only is correct, which coincides with what we've written. Whenever the resistors are in parallel to each other, so we add them like this when they are in series. So if they were in series, though, it would have been easier, RZ plus RY, right? So series ke liye we use this. Question number 29. An electric appliance has a symbol on it to indicate it is double insulated. Which statement is correct? Double insulation means that there is a wire and it is coated 2 times with an insulating material. Okay? So a 2-core flexible cable with no earth wire is used to connect it to the main supply. This is what I was talking about. So this is the correct option. B, it needs an earth wire that is connected to the fuse. No, double insulated just means that a double coating of an insulated material is there on the wire. It has nothing to do with earth wire, live wire, or a fuse. No fuse or circuit breaker is needed. No, this is not correct. A fuse or a circuit breaker would be needed. The cable should be connected to the live and earth connectors of the plug, but not the neutral. No, this is not correct. This is a very, very simple thing. A double insulated electric appliance has a cable that has a double insulation on it and has nothing to do with fuse, nothing to do with earth wire, live wire, neutral wire. So 29 mein A is the correct option. Just keep it simple. Question number 30. A length of the wire moves across the space between the poles of a magnet. A voltmeter measures the EMF generated between the two ends of the wire. What gives the highest reading on the voltmeter? Okay, the highest reading on the voltmeter would be if we move the wire fast and if the strength of the magnet is increased as well. Speed of the wire is fast and the strength of the magnet is strong. So this is all about your concepts. If you know your concepts well, so you are going to be able to answer this question in less than a minute. Okay? So B is our correct option for question number 30. Question number 31. A diagram shows a simple AC generator. Okay. What is connected to G and H so that alternating current can be provided to an external circuit? Okay, whenever we talk about an AC generator, so there are slip rings that are involved in alternating current being provided to the external circuit. So C is our correct answer. For AC generators, it's slip rings. And for DC motors, it's they are the commutators. Question number 32. The diagram shows the coil in a DC electric motor in 2 positions. As the coil rotates through 180 degrees, the direction of the current in the coil reverses from PQRS to SRQP. Yeah. So which part of the motor is responsible for reversing the current? For the reversal of the current, I just told you in the previous question that in AC generator there are slip rings, and for DC motors the same work or similar work is being done by the split ring commutators. Okay, so D is our correct option. I have never seen a question related to AC generator and DC motor just one after the other and asking about these things. Question number 33. The arrow shows the path of an alpha particle traveling towards the center of the gold nucleus. Which description of the path of the alpha particle after striking the gold nucleus is correct? Okay. Now we should know that alpha particle is a positively charged particle. Okay. And it is moving towards the center of the gold nucleus. So we should also know that nucleus is positive as well. Okay, because it has neutrons and protons. So if two positively charged objects are going to come close to one another, so they are going to repel each other. Okay, this much we should know by reading the questions. Now let's go through the options. A, the alpha particle is deflected through a very small angle towards the top of the page. No, that is not correct. Both are positively charged, so the deflection is going to be large rather than smaller. The alpha particle is deflected back along its initial path. Yes, this is correct. it is going to be deflected because both are positively charged, so they are going to repel each other, so it's going to move back. Okay. The alpha particle carries on in a straight line with no deflection. No, this can't happen because like charges repel each other. The alpha particle is captured by the nucleus and goes into orbit around it. No, this is certainly not correct. Alpha particle are positively charged, and the gold nucleus is also positively charged, just as I've told you. Since like charges repel each other, and electrostatic repulsive force acts between the alpha particle and the gold nucleus. So when alpha particle is directly exactly towards the center, look at the words now, it is going towards the center of the gold nucleus. It's directed exactly towards the center. The repulsive force is maximized, causing the particle to be deflected backwards along its original paths. So B is going to be our correct option. Okay. Question number 34. A teacher writes the nuclide equation for a fusion reaction. What is the missing number X and the missing element Q? Okay. Now this is a fusion reaction. So here there is deuterium, and we have to find this. So how can we find that? For the mass number, what we can do is that here it's 2 plus X and it is equal to 4 plus 1 over here. So 2 plus X is equal to 5. So X is equal to 5 minus 2, which is 3. So over here it is going to be 3 tritium. That is an isotope of hydrogen. ठीक है, तो यहाँ पे तो we just known कि क्या है, यहाँ पे there is 1 plus 1 and 2. This 4 and 2 shows that it is going to be helium that is being formed in the fusion reaction. ठीक है, so X की value is going to be 3 and the element Q is going to be helium. You should know that helium has a mass number or neutron number of 4 and a proton number of 2. Nucleon number, sorry, of 4 and a proton number of 2. So this is going to be helium and it's not going to be hydrogen. ठीक है, because mass number changes in hydrogen whereas the protons don't change. Okay. Question number 35. Radon gas is a source of radiation and contributes to the background radiation. What does not contribute to the background radiation? Electromagnetic rays do contribute to the background radiation. Obviously, food and drink also do. Rocks also do. Seismic waves, on the other hand, have nothing to do with the background radiation. So D is going to be our correct option. Question number 36. Two beams of radiation P and S enter an electric field as shown. Which type of radiation are P and S? So if you look at the figure, the radiation P is being attracted to the positive part of the plate, end of the plate, and S is being attracted to the negative part of the plate. So it means P is a beta particle, which is a negatively charged particle. So it is going to be attracted towards the positive end of the plate, and S isn't passing undeviated, otherwise it would have been gamma. It is deflected towards the negative side of the plate, so it is going to be an alpha particle, which is a positively charged particle. ठीक है जी. So P is a beta particle, S is an alpha particle, A is our correct option for this. Question number 37. Which change takes place in the nucleus when it decays by beta emission? Okay. In a beta emission, the neutron changes into a proton and an electron is emitted. So A is not correct. Neutron plus electron don't emit a proton. Neutron is converted into proton and an electron is emitted. This is the correct definition for beta emission. Okay. So B is going to be our correct option. Question number 38. A space probe measures the gravitational field strength at 4 different distances from a planet. the point furthest from the planet is measured first and the point nearest to the planet is measured last. So we should know that the gravitational field strength obviously is strongest when the distance is less. Okay? And as the distance increases, the gravitational field strength reduces. Okay? So if we are talking about the point furthest from the planet is measured first, so this point is going to have the least gravitational field strength, and the point nearest to the planet, which is measured last, is going to have the highest gravitational field strength. So let's look at the values. So we are basically moving in an ascending order. Okay? So 6.3, then 10, then 14, and then 20. Okay. This seems to be correct, but let's move. 10, then 14, and then 6.39. If there is no exception, so this can't happen. The simple phenomena is that the point that is furthest from the planet will have the lowest GFS and the one that is closest will have the highest GFS. So this is 20, then 14, then 6.39. This order is also not correct. 20, 14, 10, 6.3. This order is not correct because this is a descending order. 20 can't be the gravitational field strength for the point that is furthest away from the planet. It has to be less. So A is our correct option. Question number 39. The galaxy Draco 2 is a distance of 6.6 into 10 raised to the power 20 meters from Earth. What is the distance in light years? Okay. Now we know that 1 light year is equal to (9.5) into 10 raised to the power of 15. Okay. So if this has to be converted into light years, so what are we going to do? We are going to be dividing this distance with the value of 1 light year. And this is going to give us an answer of 0.6947 into 10 raised to the power 20 minus 15. We can always do that. So 0.6947 into 10 raised to the power 5. So this can be equal to be 6.9 into 10 raised to the power 4. Moving it forward, and this is going to get here. So B is our correct option. So this is a simple question. If you know the value of 1 light year, so you can easily do that. What is the possible result of a supernova explosion? Okay. Now we know that there are two paths. Okay. One is for high mass stars, which are greater than basically our sun, and one path is for the low mass stars. Okay. The first points are the same. Stellar nebula is the same for both. Either be stellar nebula.